Bonjour, welcome to Wahsa Citizen Education Center's radio Zoom classes. This is MEL3E, grade 11 workplace math, and I am Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or on the television at Bell Express View channel 972. You're always welcome to join me live through the Zoom link, which is available from your teacher and also your DEC. Our classes are scheduled Monday through Thursday, 9 to 10 in the morning, and we are now in our 4th week of our 9-week course. A reminder of what work to submit for marking. At this point, you should probably be submitting something. Support questions, the ones marked with the pencil icon, are not for marking. You decide which ones and how many to do, because they're practice questions. So if you're understanding a concept, feel free to skip questions. You don't need to do ones that you're really comfortable with. However, if you need more practice, that's totally cool too. So please just ask and I can send you more practice. The key questions, the ones marked with the key icon, are the ones to submit for grading. So please do all of those questions, showing all of your work, your steps, and your thinking. This way I can give you credit for all of your understanding. And also, if you're struggling with anything and making mistakes, this gives me more information about what's going on so that I can properly support you. There are 3 different methods for submitting your work for marking. The first is to scan your work and send it in electronically. So if you scan your completed work in through a smartphone, you can use the iPhone Notes app or the Android Google Drive app. Both have scan functions. You can also take a picture if you don't have a smartphone. It's just scanning them means that it's a smaller file and a little bit easier to send. Then you can either email it to studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca. Or you can send it to me through Facebook Messenger at bslatewahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our location, 74 Front Street, where the bright red building next to the post office. And we have a small white mailbox next to our side entrance. So you can just put it in there at any time. We're still not open up to the public, but just put it in the mailbox there and I'll get it back to you as soon as I can. The third method is to hand your work into your DEC. And your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name bslate Wahsa, so you can find me there. All of our radio Zoom classes are uploaded shortly after airing, and you can find them on YouTube, or you can share them on Facebook as well. They're all under a playlist called MEL3E, so you can find all of our lessons there. Also, there are short videos that explain common errors or confusing concepts that I've made that are also on my YouTube channel. So if you're struggling with something or you're making a consistent error, that can be a place to go that might give you some other ideas about how to do something that might be useful that you can apply to your lessons. Math is a really visual subject, so I strongly encourage you to connect to the videos, either joining me live through the Zoom link, or if that doesn't work in your life, which is completely understandable, accessing the YouTube channel and watching the replays when you have time. If you don't have reliable internet and you can't do either of those things, let me know and I can send you a copy of the recordings so that you can still access them without having to use the internet. If you have any questions or concerns, please reach out to me. My email address is bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. My Facebook is bslate Wahsa. My phone number is 807-737-1488, extension 2209. I do have access to my voicemail, so you can leave me a message now and I'll get back to you. You can also call me toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 4 p.m. and I'll get back to you as soon as I can. All right. We are on lesson 9 of our course, which is compound interest. This lesson I did rewrite a little bit this year So you may have an older version or you may have the newer version. So that just might be something that's a little bit confusing. If you're confused as we go through, it's the same information, it's just the formula is slightly different. So we're going to talk about that. And so just be aware that that might be a little bit confusing as we go. So at the end of this lesson, our learning goals are that you understand the benefits of compound interest for investments and the drawbacks for loans. And you'll be able to explain what principal, interest rate, time period, and compounding are in various situations. The success criteria, so that you know that you have met your learning goals, is that you can explain how compound interest earns more for investments, but costs more for loans. And you can identify the principal, interest rate, compounding periods, and time in order to find the final amount. All right, so let's first activate our brain with some mental math, and let's dive in and doing some math. So I'm not a believer in memorizing math facts and doing mad minutes where you just sit and you do as many math facts as you can in a minute. Instead, I believe in developing strategies that we can apply in various situations. This takes up less brain space and is more useful. So that's how we focus on just working on our math facts. So that's something that is really a useful tool, but memorization isn't necessarily the best way to go about it. So our question today is 123, take away 69, and we're going to count back in groups. So a lot of folks count back when subtracting, count back by ones, which is totally fine. But sometimes when you have bigger numbers, doing that in bigger numbers is a little bit harder. So I like to, you can also count back in groups that are friendly groups. So when I'm doing this sort of thing, I think about it on an open number line. You don't have to, but this is just how I think about it. So in my brain, how I visualize it, because visualizing can sometimes really be helpful. So if I have an open number line and I have 123 is where I'm starting and I'm taking away 59, well, I'm going to jump back in groups. So first I'm going to jump back in 20. And so that gives me to 103. So I'm counting back from 123 to 103. And that's like taking away 20. And then I'm going to take away another 20. So that gives me to 83. And then we could do two different things. We could think, well, 59 is really close to 60, which is another group of 20. So if I take away another group of 20, I'm not counting back by 20s, and I get to 63. And then because I took away one more than I needed to, then I would just have to jump back up one to get to 59. And so that would be 64. So we could do it that way. Or if you wanted to, if you didn't like having to go back too far and then coming around again, we could do the same thing. So going back by 20s. So 123 to 103 to 83. And then here we could say, okay, well, we're going to go back 10 to 73. And then we're going to go back, maybe we're going to go back 3 to 70. And then go back 6 to 64, which is 20, 40, 50, 53, 59. So you can do it either of those ways by counting back in those groups instead of counting back by ones. You don't have to count back by the same group. You can count back by friendly groups. So whatever makes the most sense for you can be a really useful way to do subtracting. Okay, so sorry, what's the actual answer? The actual answer is 64. And we got there two different ways, which are both completely fine ways. And of course, there's always other ways to do it as well. These are just two examples of this idea of counting backwards in groups. All right, mine's on. Let's see what prior learning we need to have. So just a reminder, we've talked about compound interest before in our previous lesson where we were connecting it to simple interest and seeing how they were different. So compound interest is interest that's calculated on the principal and on the interest earned. So remember, simple interest, we just calculate on the principal, but compound interest, we calculate it on the principal, and also every time that we earn interest, we add that to the principal and we calculate more interest on it. So this is exponential growth because we are growing faster. So we grow, this orange line is our compound interest, we're growing because we're adding to the principal each time. And so then we just get bigger and bigger. Our interest just grows faster and faster. I like to think about it as free money on free money, because you're making interest on your interest. So you don't have to, you're getting money for money that you didn't have before, which is really great for investments, but not helpful if you're borrowing money, because that means you also owe money on money that you didn't owe before. So it's not great for loans. And then, so just looking at this graph again, we have our simple interest, which is this blue line, which is a straight line, a linear line, that because we're earning the same amount of interest every time, and we just slowly have steps. Whereas compound interest, we're getting faster and faster because our steps are getting bigger, because we're earning interest on our interest every single time. If you don't remember about the difference between simple and compound interest, I encourage you to go back to the video on lesson 8, which connects the two, which helps us understand moving forward about compound interest. Okay, so then what are we learning new today? So first one, will you use this in real life? So we're identifying the information that we have and what we need to find. Often in our lives, we're going to come upon problems or just situations where we have some information, but not all the information. And so we need to figure out what we need to know in order to solve problems in our lives, or come up with solutions, or think critically and deal with stuff. We don't necessarily always have a very clear cut, these are all the things that you need to know, and here is what you're exactly trying to find. Usually we're missing pieces of information, we need to find it somewhere else. And so we're practicing to develop that skill. Okay, so first, when we're talking about compound interest, so now we're going to look in terms of, because before we did it with a chart, a spreadsheet, but that's not super useful to do it all the time, is having to do a full spreadsheet of every single year. So we're going to figure out the formula, but we need to know a few parts before we figure out the formula today. So first, we need to talk about compounding frequency. So first we're going to connect it back to the chart that we were doing before as we move forward, so that we can understand how it all connects. So what happens when $1,000 is invested for 7 years at 5% simple interest? So this is simple interest, this is the old one. So we know that if we were to make this chart like on a spreadsheet, for year one, our principal is $1,000, our interest is 5%, so that's $50. So we add our $50 to our principal, and that's how much we have, $1,050 at the end of that year. So in the year 2, our principal is still $1,000. We still have interest of $50, but now our total is the amount that we had before plus $50, which is now $1,100. And this continues on for all 7 years, that our principal is $1,000. We get $50 for that year, and we add that up over time. So that just means that after 7 years, we have a total of $1,350, which means we earned $350 because we earned $50 for each year for 7 years. Okay. So now let's think about what happens if we invest $1,000 for 7 years at 5%, but it's compounded yearly. So again, we have our spreadsheet chart, same idea. So year one, the same. We still have a principal of $1,000. We have $50 for interest. So at the end of the year, we have $1,050. But year 2, now our principal is $1,050. So at 5% interest, we now make $52.50. We made an extra $2.50. So we add that, and now our final amount is $1,102.50. Year 3, again, our principal goes back, right? Because the final amount goes back to our principal. We're adding more interest, and over time, that just keeps building up, because our final amount of 1 year is now our principal in the next year. And so we end up earning more interest each year. So after 7 years, we have a total of $1,407.10, which means that we earned $407.10 in those 7 years. So when we compare the simple interest to compound interest, remember, in simple interest, we earned $350. In compound interest, we earned $407.10. So we earned $57.10 more just because we were doing compound interest. We didn't do anything different, actually, just because of the way the interest was calculated. We didn't do money different. We didn't invest money differently, like more money. but because it was compounded interest, we made more money. So that's the difference between simple interest and compound interest. So it grows fast, like we were talking about before. With no interest, compounding, it's a linear line. With compound interest, it's exponential. We learn a lot. So, but is there any way that we can get more free money? So in thinking about this investments, can we get it even better? Because why not? So we know that compound interest earns more than simple interest, but the more frequently we compound, the faster the interest adds up. So we can actually, with compounding, we can do it at faster intervals. We can do it more frequently, which means that we're adding that into the amount of interest back onto our principal, and then we're calculating on that more. So what that means, here's a graph that we're looking at, and we can see, okay, so we were talking about per year. If we look at this red line, that's how fast it grows if we compound once per year. We compound every year. We add that interest back to our principal. But if we do it per month, if we look at this blue line, we can see, well, if we add our interest back to our principal every month and then calculate it, then it grows faster again over time. So this is years. So it's going to be, it takes a little bit long, it takes a while. It's not instant, but it's still going to grow faster. If we do it in weeks, is the green line, which is even a little bit faster. So it means that every week we add our compound, our interest back, and then we have a bigger principal. Or days, which is this yellow line, which is even a little bit faster than our weeks. So if we compound it more frequently, we end up making more money because we're adding our interest back to our principal more frequently and calculating it on our bigger amount. So that's just sort of the background of compound frequency. In your IEL book, this is on page 29, but that's the reason why we're looking at these things. So compounding period means the time frame in which compound interest is calculated and then added back to your principal. You can think about it like that. So compounding periods are actually often less than a year. So we need to know with our compound frequency, how many times we do that per year, because we're still talking about, when we're calculating interest, we're talking about per year. So for compounding, we have to figure out how many times do we compound, do we add our interest back to our principal in that year. So if it says annually, that means that it's one. Annual is one, so we do it one time per year. If we do it semi-annually, that means that it's 2 times per year. If we do it quarterly, that means that it's 4 times per year. Monthly is 12 times per year. Weekly is 52 times per year. And daily is 365 times a year. Remember, whenever we're talking about money and daily, we ignore leap years. So this is really, really important to remember. This is a good screen to screenshot if you're watching the video, or in your IEL book, I believe it's listed on page 29. They have a chart just similar to this. It's really important to know what these words mean in terms of numbers, because we need the numbers, but we're given the words in our problems. So we need to be able to convert, we need to be able to translate the words into the numbers so that we can calculate them. Okay, so now let's look at our compound interest formula so that we don't have to use those charts every time. So again, this is on page 29 in your IEL book. So our compound interest, and this is where it might be a little bit different depending on which booklet you have, because I've updated the information. If you have the older, if you got the booklet at the beginning of the year and you've been working on this since September, October, November, beginning of the school year, then you might still have the one that says A equals P times 1 plus I all to the exponent N. And that's totally fine. It still works. It just means that you need to do a little bit more of the background work. Whereas when I arrived on the job in November, I looked at it and thought that it made sense to me to update it and to give you something slightly different. So if you don't have this, if you don't have A equals P times 1 plus I to the exponent N, you don't need to learn this. It's just that this is one way to do this. And then we'll look at the other way if you have the other one. Again, you'll see how they're the same. So A is your final amount. So how much money you have at the end of your investment. P is your principal invested. So the amount of money you start with, or it could also be the amount of money that you borrow. I is your interest rate as a decimal per compounding period. So if you have this formula, when you do I, you need to say your interest rate as a decimal. And then you need to divide it by the number of compounding periods per year, which is what we just talked about, how that language turns into those numbers. And then N is your total number of compounding periods. So it's the number of compounding periods per year. So again, that what we just talked about, how like quarterly is 4, and the number of years, you'd multiply those two numbers together to figure out how many compoundings you have in total. Okay, so then if you have a more recent copy of the lessons, which hopefully you do, the formula is A equals P times 1 plus R divided by N, all to the exponent NT. This one looks ugly. It looks like it's confusing, but all of those things that we need to do in the background, we don't have to do in the same way. We just figure out what our variables are, and then we can plug it into the formula. We don't have to do as much thinking behind the scenes. So still, A is our final amount, and P is our principal invested, the amount of money you start with or borrow. Now, R is your interest rate expressed as a decimal, and N is your number of compounding periods per year. So this is the same, R over N is the same as what I was in the previous formula, but it's just that it looks different. You don't have to do that behind the scenes. And then T is your time in years, and N is still your number of compounding periods. It's the same, so you're multiplying those two together. So let's look at those and compare them just so that you can see how they're related. Again, this isn't something you need to know. This is just understanding the formula. For some folks, understanding the why behind things is really, really helpful. I'm not going to ask you to define these or anything. It's just so that you can use them, whichever one that you have. And because we have 2, I need to go through them right now. Hopefully in future years, we'll just have the one and we'll ignore the one that isn't as useful. Okay, so A, our final amount, is the same in both of them. P, our principal invested, is the same in both of them. Now, R, our interest rate, expressed as a decimal, divided by N, the number of compounding periods, is the same as I, which is equal to the interest rate as a decimal, divided by the number of compounding periods in 1 year. See, it's the same thing. It's just written in 2 different ways. Here with I, you need to do the division separately and then put in the formula, whereas in R over N, you do the division within the formula. And it's the same, actually the same math, it's just the order that you do it in. And then N is your number of compounding periods per year, and T is your time in years. Whereas N in the second formula is just the number of compounding periods per year times the number of years. So you're doing that math and calling it N, whereas in this formula, you're doing them separately and then multiplying them together. So again, it's the same math. It's just how you write it out is a little bit differently. You can use either one. It's completely fine. Whatever makes sense. I will be able to figure it out from your work when you hand it in. Okay, so now let's understand all of these parts. So this is on page 30 of your IEL book. This is understanding the principal. So the principal is the money, the amount. So P equals principal. So we're talking about in our formula. Oh, I'm just going to refer to always, now that we've connected the 2 formulas, I'm just going to refer to A equals P times 1 plus R over N, all to the exponent NT. That's the formula that I believe is the one that's more useful. That's the one we're going to be using moving forward. The information still applies to the other one. It's just that this breaks down all the parts. So just so you know. So the principal is how much money you have invested or borrowed. So we're going to look at 2 examples and figure out, we're just going to extract that information from here so that we know how to figure out what the principal is. So in example 1, Parker has $1,000 in a savings account at CIBC, earning 2.5% interest per year compounded monthly. If he leaves his money in this account for 5 years, how much money will be in the account at the end of 5 years? So these questions can be a lot. So it's important to be able to figure out what you need to know and what you know. So P, I like to list all my variables. So right now we're just going to pull out all we're understanding is principal. So we're just going to figure out what does P for principal equals. So how much does Parker have to start with? That's what year, how much money you're investing or borrowing. What are you starting with? Parker is starting with $10,000. So 10,000 is what P equals. And that's all we're figuring out right now. Ignoring the rest of it until we understand it more. Right now, for the first little bit, for the first part of your IEL book, you're just figuring out what does principal mean. So you can figure that out always. So example 2, Ashley borrows $25,000 at a rate of 8% per year, compounded quarterly. If she doesn't pay the loan back for 15 years, how much money will she owe at the end of the term? So again, we're just looking for principal. Principal, how much does she borrow? She borrows $25,000. So that is all how we find principal. Principal, you just pull out from the question. You just need to figure out what money is either being invested or borrowed, and that's what your principal is. Okay. So that for support questions on page 30, question 1, that is all that you're practicing. You're just making sure that you can pull the principal out of the question. Okay, understanding interest rate, also on page 30. So interest rate is your R and your N. So there's 2 parts for your interest rate. You need to know what your R is, which is the interest rate given by the bank. And you need to know your N, which is the number of compound periods in 1 year. That's what it is always. So the interest rate is the percentage of the principal that the bank is giving you if it's an investment, or charging you if it's a loan. So that's just what it actually is. So you understand why the interest rate is important. So your compounding periods are your frequency, or how often the interest is added to the principal. So that's why you need to know what the difference is between the R and the N. So let's look at our examples. So again, we have the same examples. We are looking for R and N, right? So Parker has $1,000 in a savings account at CIBC, earning 2.5% interest per year, compounded monthly. So here, that's the sentence that tells us. So R is our rate. So our rate is 2.5%. 2.5%, which remember, we need it as a decimal, not as a percent. So 2.5%, you can divide by 100, or you can just remember is 0.025, whatever works for you. So that's your rate is 0.025. And then your number of compounding periods is how you figure that out is you look in your question, wherever it says compounded, this is your word that helps you. This is your key word, is that you're doing compound interest. You need the word that says compounded. So it says compounded, and then it's going to say how frequently, compounded monthly. So because it's monthly, how many months are in a year? How many times do that in a year? You do that 12. So your N is equal to 12. Okay, so that's super important that you need this word compound. That is your key word to know that you're talking about compounded interest. And then your monthly is that one that we have to interpret based on that frequency table that we talked about before. It's on page 29, I believe. And that's all you do, how you find your R and your N. Okay, so then for example 2, Ashley borrows $25,000 at a rate of 8% per year, compounded quarterly. Okay, so our rate. So it can sometimes say rate, can sometimes say interest. That's fine. You just need to be paying attention. So our rate, our R is 8%, which is equal to 0.08. And then our N, our number of compounding periods. So we look and see, okay, so here's our word compounded, and it's compounded quarterly. So quarterly is 4. So our N is equal to 4. That's why that list is really important, because we need to be able to interpret the language, the words, and turn it into the numbers so we can put it into the formula later. And that's how you find your interest rate. That's how you understand your interest rate in a question. All right, let's keep going. So that's the support questions. Now you can practice doing that on page 31, questions 2. So let's understand the time. So this is on page 32 of your IEL book. So now we're looking at the exponent. Remember, for your time, your exponent is NT. So you have to do all of your 1 plus R over N. You do that first, and then you're going to do all of that to the exponent NT. So you have to multiply your N and your T together and do that as your exponent. So again, your time has 2 parts. So T, which is the total number of time in years, and N is the number of compounding periods in 1 year. So your N is your same. The N is the same as before. Your T is just the number of years in total. So the time represents the total number of times the investment or loan is compounded in total overall. So it's every time you add the number of times you add your interest back to your principal. So T must be in years. So you may need to convert it based on months, weeks, or days. We've done this before, but just remember that T has to be in years. So if it says that it's 9 months, then you need to figure out how many years that is by dividing it by 12. Okay, so let's look at our examples. So we're understanding time, so we need to figure out what N and T are. So Parker has $10,000 in a savings account at CIBC, earning 2.5% interest per year, compounded monthly. If he leaves his money in this account for 5 years, how much money will be in the account at the end of 5 years? So your T, your total number of years, is 5 years. So it's already in years, so it's just 5. We're good to go. And then your N is still the same as we found it before, compounded monthly. N is still 12. You don't have to write down N twice. We're just doing it right now. We're doing it twice because we're understanding the individual parts. But when you're doing question, you can just write that N down once. You don't have to write it down twice. Okay, example 2. Ashley borrows $25,000 at a rate of 8% per year, compounded quarterly. If she doesn't pay the loan back for 15 years, how much money will she owe at the end of the term? So your T, how many years? Again, this one is already in years. It's 15 years. So T is equal to 15. And N is equal to compounded quarterly. So quarterly, remember, is 4. There you go. That's understanding time. So you can now do the support questions on page 33. Question 3 looks at time. Okay, so then the important thing is putting it all together, because we're not just gonna, in life, you're not just gonna have to know the individual parts, you're gonna have to understand it all together. So this is now on page 33 of your IL book. It's putting all those pieces that we just practiced together. So an amount, so we're gonna look at a new question, and because we know how to find all the pieces, and we're gonna figure out what we do after we find all the pieces. So an amount of $4,000 is deposited into a savings account at a rate of 7% compounded monthly. Calculate the total balance after 5 years. So how I like to do this is I like to figure out all of my variables first and then put them into my formula. So total balance is what I'm looking for. So I'm looking for A. How much do I have? My principal, P, is equal to 4,000. That's how much is the beginning, how much I'm depositing. My rate is 7%, which is 0.07. My N is 12 because it's compounded monthly. And my T is 5 because it says after 5 years. So I always like to write down all of my variables, and I strongly encourage you to do it as well, because then I can see if you made a mistake interpreting the question, or if you made a mistake doing a calculation later, but you understood all of this. If you figured all this out, that I can give you marks for figuring all this out, even if you make a mistake later with your math, with your calculation. So this is important. I strongly encourage you to write out your variables. So then I write out my formula. A equals P times 1 plus R over N, all to the exponent N times T. And then my next line, I fill in what I know and leave what I don't know. So A is what I'm finding, so I still have A equals. My principal is P, so I replace my P with 4,000. Then my brackets times 1 is still just 1, plus my R is 0.07 divided by N, which is 12. And then I do close my bracket, and then in my exponent, I do 12, which is my N, times 5, which is my number of years. Again, you can do this if you wanted to do this, not all in the equation. You don't have to. You could do it as a side note, but either way, show me what you're doing so that I understand where your numbers are coming from. Then you can either do this all in one step in your calculator, which is how I do it in Desmos, because you can just easily put it all in, or you can put it all in your calculator if you have a scientific calculator that you're using either on your phone or just as a old-fashioned calculator that's only a calculator, or you can do it in parts and write it down. So you can do A equals 4,000 times, so then add what was in the brackets. So 1 plus, if you do 0.07 divided by 12, that's 0.0583. So that's 1.00583. And then all to the exponent of 60, because 12 times 5 is equal to 60. Now, if you're going to write down your decimal place, and it's more than 5 places, I would strongly suggest that you keep it in your calculator to make the most accurate calculation. You can, if it's less than that, you can just write it down. But if you round this, then you're going to get a different answer than the correct answer. So if you can get your calculator to hold that information in its little brain, or if you can do it on Desmos on the computer, remember that you can download the Desmos app for free, the scientific calculator, and you can do it on your phone if you have a smartphone. Then it holds the information and you're going to get an accurate answer. Whereas if you round it, then you're not going to get as accurate. You can write down the rounded answer if you want, but if it's more than 5 decimal places, it's likely you're going to lose a bunch of information. It's not the end of the world. I'll still probably figure it out, especially if you show me your work. This is why showing me your work is really important, because then I can understand where your numbers are coming from. If they don't match my numbers exactly, but I can see how you got there, then I can say, oh, they just rounded. This isn't an error. They just rounded, and that's fine. But if you can avoid rounding, that's really important when dealing with money, because all the little bits, all the little cents add up over time. And because we're talking about 60 compounding periods, that's a lot of time for those little rounding errors to change. Okay. Anyway, so then if you do that and you multiply that, you do 4,000 times 1.00583 to the exponent of 60, you get $5,670.50. So the total balance of the savings account after 5 years is $5,670.50. And that's how we actually do these compounding questions. So we don't have to do the spreadsheet all the time. We can just do this calculation. So again, compounding is great for investments, but also applies to loans and debts. So it means that your interest is added more frequently to the amount that you own. And so that's something to remember. So let's do a debt question. So Xavier's credit card balance is $800 at the beginning of July with an interest rate of 19.99% compounded daily. He forgot to pay his bill until the next month. How much interest did he have to pay? So how much interest is what we're looking for. So interest, we haven't talked a lot about, but remember in terms of how you find an interest amount. So that's your total amount is equal to the principal plus interest. So we're just gonna have to figure that out later. We're gonna have to do a separate step, sorry. So your principal is 800, how much you owe at the beginning. Your interest rate is 19.99%, which is 0.1999. Your N is 365 because it's compounded daily. Your T is the month of July. So the month of July is 31 days divided by 365, right? Because we need it per year. So that your T is a little bit different this time. So we have to do 31 days divided by 365 to figure out how much time how many days we're actually doing. So then our formula, we have A equals P times 1 plus R over N, all to the exponent NT. Remember, you're never going to have this memorized. You can always look it up. That is fine. And so then we substitute in our numbers that we know from listing them off in our variables. So A equals 800 times 1 plus 0.1999 divided by 365, all to the exponent 365 times 31 divided by 365. Remember, you can do this as a decimal if you want, but if you do it as decimal, you might end up having rounding errors. So it just kind of makes sense to leave it as a fraction when you're doing it, or as a division problem as you're doing it in your calculator. You need to figure out how your calculator works best. So then that simplifies to 800 times 1.00054, all to the exponent of 31, which is equal to $813.69. So have we answered the question? No, because it was how much interest did he have to pay? He didn't have to pay $813.69 in interest because he already owed $800. That was the amount of money that he spent. So to figure out how much interest, remember that the amount is equal to the principal plus interest. So interest is equal to the amount, take away your principal. So we have our amount, $813.69, take away $800. That's how much the principal was. So that means the interest is $13.39. So Xavier has to pay $13.39 in interest for the credit card balance that he carried in July. So just because he didn't pay his credit card, he has to pay an extra $13.39 in interest. So that's how it adds up in terms of borrowing money, which isn't great. Just something to be aware of. So now you can do the support questions on page 35. Question 4 is putting it all together. Great, so let's look at another example because these ones take practice. So it's a little bit different than what we've been doing before. It's a fair amount of math, so it's really important to practice. So Chris wants to invest $1,000 at 4.25% compounded quarterly. How much bigger will their investment be after 20 years opposed to after 10 years? So this question is asking us to do it in 2 different ways to figure out, to compare, to figure out, is it better to do it for 10 years or to do it for 20 years? So first, we're going to do it for 20 years. And I like to organize my information. And 10 years. So I like to give myself labels so that I know what I'm talking about. I appreciate that too, so that I know what you're talking about. So then principal is equal to $1,000. That's how much he's investing, or they're investing. The rate, R, is equal to 4.25%. 4.25%, which is equal to 0.0425. And my compounding period, so here's my word compounding, compounded quarterly, so that's 4. And my T, how many years? Well, this is the 20 years example, so we're going to do T equals 20. So then A is equal to P times 1 plus R over N, all to the exponent NT. So it's equal to $1,000 times 1 plus 0.0425 divided by 4, all to the exponent 4 times 20. And what does that equal? I'm going to just do it on my Desmos calculator so that you can see how I actually do it on the calculator. So I just put it all in 1,000 times brackets 1 plus 0.0425 divided by 4. So if you look here and we can see this 4 is dividing 1 plus 0.0425. That is not what I want. My Desmos, my calculator has tried to do something that I don't want. So I need to delete that, and I need to make sure that I'm just highlighting what I want to be divided. So it's really important that you're paying attention, because your calculator, either on Desmos or on another calculator on your phone or on a classic calculator, it might do something that you don't mean it to do. So it's really important that you're paying attention. So now here that I've rearranged it, I can see it's 1 plus, and it's only 0.0425 divided by 4. So that's really important to pay attention to. Then to the exponent, this A to the exponent B, A to the little b, is your exponent button that you press on Desmos. And then I can do, I'm going to do put in brackets 4 times 20, because I want the 4 times 20, all my brackets are all my exponent. And that gives me $2,329.18. 23.29.18. $329.18. So that's how much I get over 20 years. So let's do the same thing for 10 years. So our P is still 1,000. Our R is still 0.0425. Our N is equal to 4 still. And our T, this is the only part that changes, is equal to 10. So then our formula is still the same. You don't have to rewrite it if you don't want to. I encourage you to, so that you make sure you're getting comfortable with it. But it's equal to 1,000 times 1 plus 0.0425 divided by 4, all to the exponent 4 times 10. So then looking at our Desmos calculator, the nice thing with Desmos is that I can actually just go in. All I need to change is this 20 to 10, and it's going to change my whole number. Everything else is the same. So I'm just cheating. I'm doing it quickly. It's not cheating. I'm just doing it quickly. So that gives me $1,526.17. So 1526.17. 1526.17. Okay, so the question asks, how much bigger will my investment be after 20 years opposed to after 15 years? So let's compare the two. So my 20 years is $2,329.18. Take away $1,526.17. So let's go to Desmos and calculate those, that difference. 23, 29, 18. Take away 15, 26, 17. So $803.01. So doing it for a longer period of time gives us more money. So that's just important with compounding interest. Doing it for longer is better. If you are investing, if you're not investing, if you're borrowing, doing it shorter is better. Okay. Let's quickly consolidate. So our lesson 9 highlights for compound interest. So compound interest grows exponentially. So that means that the pattern increases or decreases at a constant ratio. So it's the same, you're multiplying or dividing by the same amount each time. Our formula is A equals P times 1 plus R over N, all to the exponent NT, where remember A is our final amount, P is our principal, R is our interest rate as a decimal, T is our time in years, and N is our number of compounding periods. And then also remember that you're finding just your interest amount, the money amount, is your total amount minus your principal. So with compounding interest, we find the principal and our interest all combined, whereas with simple interest, we're just calculating our interest, and then we need to add it to our principal to find out how much. That's one way that these two are different. So it's just important to remember that if you're looking for your interest amount money only, you need to subtract your principal from the amount that you calculated. Okay, so our success criteria. I can now explain how compound interest earns more for investments, but costs more for loans. So hopefully you can see now how when you are adding up that extra bit of money added onto your interest, into your principal each time, that extra bit of money, which is interest, added onto your principal each time, is going to earn you more for investments because you're adding money to money and then you're going to grow. But it also means that you cost more for loans because adding that interest onto your principal each time means that now you're going to owe more on owing more. And then also the second piece about this is that for investment, doing it for longer is better because you earn more money, but doing for loans, doing it shorter is for better because you don't have to pay as much extra money. So then also now you can hopefully identify the principal, the interest rate, the compounding periods, and the time in order to find your final amount. So you're able to look at a question or a situation and find all of these different pieces so that you can then calculate them together to find your total amount overall. So that's sort of key, is picking up the pieces and putting them all together is what you need to do with these sorts of questions. So it can be a little bit complicated. That's why I strongly encourage you to write out your variables so that you can see all of the pieces and you know if you're missing a piece. And if you need to figure that out, or maybe you missed that from reading the question, is super, super useful. All right, so if you have any questions, please contact me. This is one of our heavier math lessons. So, I mean, all of what we're doing is math, but this calculation is a little bit more heavy on that calculation side for this course. So that's a lot of the other stuff is sort of logical and connecting to real life things, whereas this is very real life. Most of us are borrowing money, if it's a credit card or other ways, a mortgage, other ways that we're borrowing money, or maybe hopefully investing money in terms of retirement savings or education funds for folks that we care about or whatever. So this is very real life, but most of us don't do the calculations. We trust them to the bank or we trust it to an online calculator. Understanding what's going on can be really useful, but it is a little bit on the math heavy side, which I can understand can be daunting for many folks. So if this lesson is confusing and you want to talk through parts of it, please reach out and contact me. I will try to check in with folks, but really being an independent course means that you are a distance education course, you need to reach out if you need support, and I'm happy to help you, but it's hard for me to not be in your face because I'm not in your face. I'm not there in your classroom, in your space, being able to say, how you doing? So reach out to me. Again, I can't express it enough to please reach out if this is hard for you. Totally understandable. It can be confusing. So just please reach out. How you do that is by calling 807-737-1488, extension 2209, or toll free. You can call 1-800-667-3703, still extension 2209. You can email me at bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. You can connect with me through Facebook at bslate Wahsa, or you can watch the replay of this when I upload it onto YouTube so that you can go back over those pieces and slow things down, pause them. I really encourage you to do that if that's helpful. My office hours are Monday through Friday, 9 a.m. to 4 p.m. If you need support outside of those hours, feel free to reach out and we can try to schedule something that works for both of us. I can understand that life is full and many of us have multiple responsibilities. This isn't the only thing that you're doing. So if you can't reach out to me between 9 and 4, connect with me in some way, call me and leave a message when you can, or send me an email or Facebook message, and we can try to arrange some time that I can support you. Again, I really want to support you as much as I can and know that I might need to work around life in general. Thanks so much for joining me today. I hope you have luck with this lesson or are able to understand it and move forward in the course. And we'll switch.